All right, let's just do a more complex example. Again, it's not really anything new. We're just using stuff that we already learned and just applying it to a new procedure. So here we're going to have lead 2 nitrate as an aqueous solution react with some sodium iodide as an aqueous solution to form a precipitation reaction where our precipitate is lead iodide as a solid. And then we're going to be left with some sodium nitrate in solution. Cool. So then our question says 10.4 grams of lead 2 nitrate is added to 66.9 milliliters of 1.20 molar sodium iodide. If 14.1 grams of lead iodide is collected, what is the percent yield? And so again, we want to kind of think about what we want. Again, this is a word type of problem. Word problems can be tricky. You really want to organize your thoughts. And of course, it always comes down to practice. So what we want here is percent yield. That's what the question is asking for. And we know that percent yield is equal to the actual yield over the theoretical yield times 100%. If we read the question carefully, we can tell that we are given an actual yield, right? We got 14.1 grams of our lead iodide, so that can be plugged in for our actual yield. The next thing we need to think about is what's the theoretical yield? That's what the other part of the question. And we see that we're combining two things. So we're going to have to first determine, which one is the limiting reagent and thus our theoretical yield. So again, we'll start this just like we did the other ones. We can start with the 10.4 grams of lead nitrate. That's not a conversion unit, so that's a good place to start. So I have my 10.4 grams of lead nitrate. I want to get to moles of A as quickly as I can. So then, since I just have mass here, I can use my molar mass, and the molar mass of lead nitrate is 331.2 grams per mole. Grams and grams go ahead and cancel out. Next up, I use my stoichiometric coefficients, and I can see for every 1 lead nitrate, I get 1 lead iodide. So that takes care of that. And then I think about going to what I actually want, which is my grams of lead iodide, right? I need that to plug into my theoretical yield. So I'll use the molar mass of lead iodide, which I got as 461.01 grams per mole to get a theoretical yield of 14.5 grams of lead iodide. So I have enough lead nitrate to make 14.5 grams of lead iodide, but of course I have to think about my other component. What if the other component's the limiting reagent? If I think about what information I have about my other component, I have that it's 66.9 milliliters, and then I also have that it's a 1.2 molar solution of sodium iodide. Again, the 1.2 molar means 1.20 moles of sodium iodide per 1 liter of solution. So I'll start off with the thing that's not a conversion, my 66.9 milliliters. 66.9 milliliters of my solution. I then see I can have another unit of volume here, right? The liters of solution, but that's in liters, so I need to get to liters first. So I can convert my milliliters to liters. After that, I can then use my molarity. So I know it's 1.20 moles of my sodium iodide per 1 liter of solution. So now I'm at my moles of iodide. Since I'm at my moles of A, I can go to moles of B using my stoichiometric coefficients. And I see that I need 2 sodium iodides for every 1 lead iodide. So 2 NaA, NaI per 1 PbI2. Now, if I think about it, now I'm at moles of lead iodide. So the last thing I need to do is just switch it over to grams using my molar mass. I do the calculations. I end up with 18.5 grams of lead iodide, right? So the sodium iodide is in excess, and my limiting reagent is the lead nitrate, which means that my real theoretical yield is this 14.5 grams. I can take that value, I can plug it into my theoretical value, and then I'll get 14.1 grams is my actual yield, divided by 14.5 grams is my theoretical yield, multiply by 100%, and I get 97.2% as my final percent yield. Again, as always, practice. This is more difficult than it looks. Right, I know what I'm doing, so I can make it look easier because I know what the right steps already are. I already know how to get to the end point. You may not, so of course you need to practice.